Woohoo, we're live. This is Math 75, section 2.2, page 2. It's very exciting. It's all about the twos. And we are on the second page. Sorry, I'm changing the lighting. Just that's very exciting, I know. We are on the second page, and this is a page of applications to graphs of parabolas. So graphs of quadratics, which will be parabolas. And there are a couple things that the book will want to ask you about. So I wanted to go over these things so you're prepared. So the first thing is something we had talked about before. If you recall, back in chapter 1, we talked about ROC, rate of change. And now we're going to be talking about the average rate of change. We've added a word that I was talking about the book hasn't discovered yet. And that is looking at what's happening between x equals 2 and x equals 4 in this lovely little quadratic, y equals 0.5 x squared plus 3x plus 8. So this is a parabola. We can tell it's a parabola that opens upward. And so we could graph it and take a look at what's happening. But basically, what we want to do here is we want to take a look to see if between x equals 2 and x equals 4, what is happening with the polynomial itself. How is y changing? So the actual way you do this is pretty straightforward. What you're going to do is you take a look what happens at x equals 4. Okay, so at x equals 4, we've got y equals 0.5 times 4 squared plus 3 times 4 plus 8. Okay, and I get out my handy dandy calculator here, or I do this in my head. 16 times 0.5 is 8, plus 12 plus 8 is probably 28. Let's hope it is. If it's not, I'm just testing to make sure you're paying attention. Then we look at what happens when x equals 2. So y equals 0.5 times quantity 2 squared plus 3 times 2 plus 8. Okay, this is 4 times 1/2 is 2 plus 6 is 8 plus 8 is 16. So when x was 2, y was 16. When x is 4, y is 28, which it looks like there's an increase. The average rate of change again, it's that change in y over change in x, or y2 minus y1. It's the slope formula, basically. So the difference between the y's is 28 minus 16, and the difference in the x's is 4 minus 2. So this is 12 over 2, which is 6. So what does that mean? Well, that means that on average, every time between x equals 2 and x equals 4, on average, as x increases by 1 unit, y increases by 6. That's basically the slope, right? You go over 1 and up 6. Now, what is happening here? Well, the problem is we know we have a parabola, but if we don't graph this, we won't know. All we know is that when x equals 2, the y value is smaller, and when x equals 4, the y value is larger. So we could be here on the graph, or we could be here on the graph. We could be between this point and this point. We could be between this point and this point. So it's hard to know exactly where we are on the graph, given that we haven't graphed it. And here I haven't shown you any scale. So it's hard to know whether we're looking at this kind of a difference or this difference or two really close points, because we don't know the scale of the graph. So all this tells us is that as X is increasing, Y is increasing. And could it maybe go through a dip where temporarily Y goes down and then comes back up? Or could it be going just straight up? We don't know without the graph. So this problem is a partial question. It's an important question, but keep in mind, to know fully what's going on with the function, we would actually have to graph it. Okay, which I'm not going to do, but you guys are absolutely encouraged to go and look at the graph of this. But what I'm going to do right now is take a look at this next problem. Woohoo. This is one of the weirdest problems in the history of problems. I have tried to come up with other ways to phrase it, and I have failed miserably. And the book has failed even worse than I have. Or did they fail better or did they fail worse? That's a hard question. I don't know if their failure was better than my failure or worse than my failure. Anyway, the way the book talks about this is incomprehensible, but I think it's a really interesting question, following up from the previous one that I just pointed to that you can't see, but following up from the one we just did. This is a problem which talks again about, now in this case, this is a parabola that opens downwards. A is negative. And we're told that this is a total revenue function. So this is R of X. And as you can see, I have very clumsily scanned this from the book, but this is the picture in the book. And X, which is down here, the horizontal axis, is the number of units. And we've got very little letters, so let me make them bigger so they're easier to see here. This is A, this is B, and this is C. And Y, or R of X, is measured presumably in dollars. We're not told, but I assume most of these problems are done in dollars. So, first question. Is the average rate of change of revenue negative? So when is the average rate of change negative? From X equals A to X equals B, or X equals B to X equals C. Okay, so I'm going to get out my handy dandy, lovely highlighters. Let's see if I can make some color happen. So from A to B, this may not be visible. Is that even visible? Kind of. You can kind of see that. From A to B, this is my yellow one. And then from B to C, hopefully this is reminding you a lot of what I just wrote on the previous problem. That's that blue one. So here's the first one. Here's the first part. Here's the second part. So this is 1. This is 2. So the question is, what's going on here? And as X increases from A to B, the Y value increases. So you've got a line. If we draw a line between the 2 points, the slope is positive. So the average rate of change is positive. Now, what happens from B to C? Well, from B to C, B looks like, if I were going to guess, I'm going to guess that's the vertex. We don't know for sure, but it looks awfully close to the vertex. So this is pretty much the maximum revenue can be. You don't necessarily want to maximize revenue. We'll talk about that hopefully later, possibly in 2.3. But there are a lot of things that could happen that would make you not want to operate at your maximum revenue, depending on what your costs are, depending on what your market share is. But this does appear to be the maximum revenue. So as we move our production from B to C, which does increase market share, that's not nothing. So as we move from B to C, we notice that even though we're increasing production, we're decreasing revenue. Now, why would this happen? That's a very good question, because in our model, the revenue was exactly equal to the price times the quantity. And what happens in business, if you think about it, if you're selling whatever you're selling, how do you get people to buy it more? Well, either you do a bunch of advertising and convince everybody that they need it, or you get like a celebrity to say, "Oh, I love this thing, so you should have this thing." Or the easier way to do it is you drop the price. So if you offer a sale, if you lower the price, if you make a big deal about it, more people want to buy it. But if you lower the price, your overall revenue is going to go down. So these are some things that can happen. So this is what's happening here probably. The price went down. In order to sell, in order to move production over, we had to lower the price. We didn't mind because maybe we're just trying to get market share. We want everyone buying our stuff. If everyone buys our burrito, then it'll put our competitors out of the burrito business. Blah, ha, ha, ha. So as I move from B to C, though, my revenue goes down. So my up here, my average rate of change, which is delta Y over delta X, even though X is increasing as we move from B to C, our revenue is going down. So this is a line segment that has a negative slope. So the average rate of change is negative. So the answer is, so again, they phrase this so terribly, is the average rate of change negative from here or from there? And the answer is it is negative from x equals b to x equals c. That's where it's negative. Woohoo. Okay, part B. You think part A was complicated and confusing? Eh. B's very much like, hold my drink. So I'm going to redraw this situation. So there's A, somewhere near the top is B, and C is somewhere over here. Would the number of units D need to satisfy D is less than B? So should we put the D over here? Or D is greater than B, so should we put the D over here? For the average rate of change of revenue from x equals A to x equals D to be greater than that of x equals A to x equals B. So here's A to B. Okay. Now, from, let's call this number 1. Let's call this point number 2. So from A to D number 1, I'm going to do in yellow. Let's see if that, ooh, can't quite see. Sorry about that. From A to D1, I'm going to do in yellow. Let's see if I can do this. You see that? It's not great. Okay. And from A to D2, I'm going to draw this in blue. So this is going to be from there to there. Okay, so I've got the 3. I've got from A to D1, A to B, and A to D2. Oh, and yet again, I'm drawing something that you guys can't see. Isn't that brilliant? Oh, you gotta love these teachers who have no idea how video works. Okay, so let's review what I just did. I've got the situation where I've got A, B, and C. I'm being asked to put D either between A and B or between B and C so that I make a new line segment. And I will look at these line segments and decide if I have this be M1 and I have this be M2 and I have this be M, what is the order from smallest to largest of the slopes? And I'll remind you that the smallest slope, well, the smallest, the flattest slope, if it's straight flat, right, if you go straight across, that equals 0. As this line segment starts to tip up and get steeper, the slope will get steeper. So I've got 0 is less than M sub 2 is less than the regular slope. That was the regular slope is the one that goes from A to B. So this big old point is A. This is B. And then that's smaller than m sub 1. So in other words, what it's saying is this slope right here is bigger than that slope. So this d1 is a bigger slope. A to d2, this choice, because it's a little bit further down, this is a smaller slope. So we want the average rate of change of revenue from x equals a to this new point D to be greater than this one. So we have to pick this point. This is the one we're interested in. So we need to choose that D is less than B. Congratulations. You just possibly made it through the most confusing problem in this whole book. And if it still doesn't make sense, please ask questions. There's a question just like this in the homework. Hopefully when you go through it the second time, it starts to shake out and make a little sense. What we're interested in is we're interested in getting the concept of an average rate of change, which is the same as the slope of these little line segments. Woohoo, we're halfway through chapter 2. Yay! Happy parabolaing.